Sometimes there's a mystery detectives cannot solve. Their problems only multiply, solutions just evolve. And then comes the great divide that splits things all apart. Then you need the master, a man with math and heart. He's Abacus the Great, he'll clear up all suspicion. He'll distribute, regroup, solve for X, cause he's a math magician. Add, subtract, multiply, divide, all things which he excels. Polygons, fractions, a man of many spells. The steps are simple, one by one, the numbers infinite. For help in math, both big and small, call Abacus the Great!
Abacus, you're starting.
Oh my goodness! Hi guys! Sorry about that. I was, distracted.
No, you weren't. You're just late.
I was not just late.
Uh-huh.
Anyway, thanks for getting me here, Helix. Welcome, apprentices, to the division episode of Abacus the Great! Let's start off like normal. Helix, take it away.
Division is a type of math related to multiplication. They're done a little different, but in the same family. Division is represented by many different symbols. Align with your dots, a forward slash, and even as a fraction. The basics of division is breaking it into groups. 12 divided by 3 is 4 different groups. You can always check your work by doing the multiplication. If you do 3 multiplied 4, your answer will be 12. That is division.
So dividing is simply the act of taking things and putting it into groups. Like if I take my class of 24 students and divide them into 2 groups, there's going to be 12 kids per group. If we think about that with bigger numbers, if Johnny has 648 Skittles, and he wants to divide those by color. If there are 6 colors and an even amount of each color, how many of each color does Johnny have? We'll get to solving that problem after a little bit of learning. Let's go down into my computer and get started. Okay, so if we just look at the basic definition of division, division is the action of separating something into parts or the process of being separated. Now, if we want to talk about that in mathematical terms, we're more specifically talking about numbers. We're going to separate numbers into parts. Now, I've got this little daffodil up here in the corner of the screen. Let's say I have 15 of those daffodils. Now, right now, I've just very purposefully put those 15 daffodils just kind of all over the place. So at this point, I'm going to start with the number 15. Okay, I have the number 15 for those 15 daffodils. Now, let's say I have 3 different kids that I want to separate these daffodils amongst. I want to know how many daffodils each kid is going to get. So I'm going to take this. Now remember, division has 3 different symbols. I could write this as 15 divided by my 3 kids. I could write it as 15 divided by my 3 kids. Or I could write it as 15 as a fraction divided by my 3 kids. So I'm ultimately wanting to figure out what is 15 divided into groups of 3, or 15 divided into 3 groups, depending on how you want to look at it. The question can be worded various different ways, but in this case, we're going to be 15 divided into 3 different groups. So if I were to start separating these into the groups, I've got 1 kid, 2 kids, 3 kids, and so on all the way up. First kid, second kid, third kid. First kid, second kid, third kid. So I'm just going to divide these flowers into each of those groups with my children. And I have 15 divided into 3 different groups. Now my answer is going to be how many of them are in each group. So I want to look at that one group there. I took 15 and I divided it into 3 different groups. We have 1, 2, 3, 4, and 5. So 15 divided by 3, if I take those 15 daffodils and divide it amongst my 3 children, each kid is going to get 5 daffodils. Let's take a look at another problem. Let's try, let's say 18 divided by 2. Now again, if I want to represent this as my daffodils, I need 18 of my daffodils divided into groups of 2. So if we were to count those daffodils on the screen now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 daffodils that I have divided into 2 very distinct groups. Then I want to know how many daffodils are in each group. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 daffodils per group. Now, if you listen to Helix's song, he told you that you can use multiplication to check your division. This shows you the relationship between multiplication and division and the fact that they are in the same family. So if I had 18 divided by 2 equals 9, then if I reverse that, I should be able to say 9 times 2 equals 2, 4, 6, 8, 10, 12, 14, 16. 9 twos is my original 18. So that shows us then the relationship between 18 divided by 2 equaling 9. I reverse that out. 9 times 2 then should equal 18. Let's take a look at one more problem. So here I have a visual representation of 24 divided by 4. I started by putting out 24 of my daffodils just so we can have that picture of it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now I want to do 24 divided by 4. So I'm going to take those 24 daffodils and I'm going to divide them into 4 even groups. Now I've already got them lined up, so I should easily be able to just go 1, 2, 3, and 4. And then the answer to that division problem would be how many are in each group. So you have 1, 2, 3, 4, 5, 6, showing us that 24 divided by 4 does in fact equal 6. We could check that work again by doing the opposite. 6 multiply 4, 6, 12, 18, 24. So 6 times 4 does in fact equal 24, showing us that 24 divided by 4 does equal 6. Let's take a look at one more thing, and this is for more complex division problem. It's called long division. Now you're probably not going to get this right off the bat, but I'm going to show it to you because we're going to need it to solve our original problem from the beginning. If I have, let's say, 128, and I want to divide that by 4. So now it's a bigger number. I could theoretically skip count 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, all the way up to 128 and get the right answer. But chances are I'm going to skip count wrong somewhere along the way. I'm going to lose count. I'm not going to get to the correct answer. This is where what we call long division comes into play. If I have a little house and I put that 128 inside the house, this is the one final way that division can be represented. Inside the house, 128 divided by 4. Now there's a fun little saying. Daddy, mother, sister, brother, Rover. Now, daddy, mother, sister, brother, Rover all stand for the steps of long division. Divide, multiply, subtract, bring down, repeat. Now, generally speaking, there's a lot of steps along the way, but we want to try and keep this episode as close to 15 minutes as possible. So we're just going to jump right into the long division, skipping partial product division and all of that good stuff. So 4 into 128, I want to start thinking about 4 into each individual digit. Now, I can't do 4 into the 100, but I can do 4 into 12, which would be the 120. 4, 8, 12. 4 goes into 12 3 times. I'm dividing. 3 times 4 gives me 12. I just multiplied. Daddy divide, mother multiply. Sister subtract. 12 subtract 12 gives me a 0. And then brother bring down. I'm going to bring down that last digit that I haven't used yet. Now 4 goes into 8. 4, 8. 2 times. So that was Rover repeat. Daddy divide again. Mother multiply again. 2 times 4 is 8. 8 subtract 8 is 0. There is no more repeat. So therefore, 4 goes into 128 32 times. So let's take a look at our original problem. Johnny has 648 Skittles. He wants to divide them into groups by color. There are 6 colors. If there's an even amount of each color, how many are in each group? So this is going to get us 648, and we are going to divide that by 6. So daddy, mother, sister, brother, Rover. 6 divides into 6. Daddy divide 1 time. Mother multiply. 1 times 6 is 6. Sister subtract. 6 subtract 6 is 0. Brother bring down. I have a 4. Can 6 go into 4? No, it can't. So I'm just going to put a 0 up here. 6 goes into 4 0 times. And then we're going to brother bring down again. So we have 48. 6 goes into 48 8 times. Mother multiply. 8 times 6 is 48. Sister subtract. 48 subtract 48 is 0. There's no more brother to bring down, so we don't need to repeat again. He has 108 of each kind of Skittle. That, my friends, is a lot of Skittles. Let's go ahead and take it to our student question of the week.
Joey has 1 pie. He cut it into this angle. What angle is that? Is it a right angle, an obtuse angle, or an acute angle?
Thank you for that question, Ryan. To be able to answer this, we're going to have a basic understanding of the classifying of angles. Now, for starters, we have the 3 types of angles that he mentioned: a right angle, an acute angle, and an obtuse angle. Now, if we draw a box right in here, you're going to be able to see what a right angle is. A right angle is when it points to exactly 90 degrees. Now, notice it goes along the bottom. Now, anything bigger than that 90 degrees is going to be an obtuse angle, and anything smaller than that 90 degrees is going to be an acute angle. Now, to be able to measure the angle of that slice of pie, we are going to have to move our protractor up onto the angle. Now, that bottom of my protractor is going to have to line up with at least one of those lines. So let's rotate the protractor here, and then we're going to move it up there and make sure that it's lined up exactly with one of those lines. Now, you'll notice that one of them is pointing up at a 0. So we're going to measure off of that 0. We're going to draw a line out further so I can see right about exactly where this is pointing. And if we measure off of that 0, you're going to see that we measure approximately 145 degrees. Now, 145 degrees then is bigger than that 90 degrees. Therefore, it is going to be an obtuse angle of pi that you have cut. Thank you again for that question there, Ryan. Now we're going to go off to our magic trick. Now, as promised, our magic trick this week is going to be a little more STEM, science, technology, engineering, and math. But it's still going to be magical. Let's get to it. All right, for today's magic trick, we are going to make a flaming hot Cheeto volcano. Now I know what you're thinking. Abacus? Where's the math? Well, math can be found everywhere, so let's see where it comes up. We are going to take half a bag of flaming hot Cheetos, and we are going to use our ninja here to divide it into thousands of little pieces. So let's do that. Now we have here kind of a fiery powder of death. Let's kind of mix that up a little bit and take it a little bit further. Now we're going to dump this out. And we kind of just have here a really nice red powder. Next, we're going to divide 2 packs of Tic Tacs. So let's go ahead and get these opened up. And again, we are going to divide those 2 packages of Tic Tacs into thousands of little pieces. Now we want to make sure we have a fine little powder. And we still got lots of little chunks there, so let's see what we can do here. Now we're going to take our powder and we are going to add our flaming hot Cheeto powder to that. Ooh, we're spilling. And we'll just let the machine do a little mix for us so that those are all mixed up together. So what we end up with is a pretty amazingly reddish, orangish, flaming hot, orange flavored powder of not very tastiness. And we're going to put that back onto our plate here. And we're going to form it into a volcano. So we kind of just want it to be a mountain of goodness. Now, it should go without saying, but this next part is maybe not try this at home, or if you're going to try it at home, make sure you have a parent trying it with you. Let's go outside and see what happens when we light this on fire. All right, now again, if you're going to try this at home, please make sure you do it with parental supervision, because anytime you're gonna play with fire, you wanna make sure it's done safely. Which is why I also have a little can of fire extinguishing here, just in case. Now, all we have to do is combine fire. So we're gonna add fire to our divided up pieces of Cheetos and Tic Tacs that we added together. Look at all this math we're doing. And let's see what happens. So something's not working quite right. So as with any experiment, we're going to try and change things up a little bit. I went in and shredded up some more Tic Tacs. Maybe adding a little bit more sugar to this will give us a more desired result. So let's mix that into there and just see what happens. There is our fiery red goodness. Here's our fire. Let's go. All right, we're out of Tic Tacs, but Tic Tacs are basically sugar, so let's see what happens if we just add sugar to it. And of course, mix that back up. And here we go. Too much Tic Tac, not enough Cheeto? Well, let's find out. Okay, so here's the conclusion I've come to. You see an experiment on YouTube? It might not be true. So what we have here for our math problem is if you take half a bag of Cheetos, divide it into 1,000 pieces, and add that to 2 packages of Tic Tacs, divide it into 1,000 pieces, and then add to those fire, you get nothing. It equals 0. We must have multiplied by 0 somewhere along the way, but I promised you a magic trick with STEM and science, and I promised you a volcano, so here we go. Form that into more of a volcano. Not quite sugar, but another white powder. So we're gonna add in some baking soda and add in some vinegar, and you, my friends, are going to get the volcano you deserve. Let's zoom in. And that, my kids, is more of the volcano that you deserved. Keep this in mind, that everything you see on YouTube is not true. That's it for another stellar episode of Abacus the Great. Until next time, as always, make sure your math is magical. Hey guys, if you guys like what you're seeing, make sure you let me know by hitting that like button down below. If you want to keep up to date on all of the new episodes of Abacus the Great coming out, be sure to click subscribe. Remember, there's several different ways that you can get in touch with me. You can either email abacusthegreat2020@gmail.com. You can leave comments just down below on the video, or you can go to flipgrid.com/abacusthegreat and record your very own video that could end up on the next episode of Abacus. Math is magical, guys. We'll see you next time.